Section 5.2 is where we are going to look at finding congruent triangles. So you have two congruent polygons if all of the parts of one polygon is congruent to the other parts. These are called corresponding parts. So in a triangle or any kind of polygon, you have corresponding angles and corresponding sides. So therefore, two triangles are congruent if and only if their corresponding parts are congruent. We can abbreviate this part, corresponding parts of congruent triangles are congruent, by this acronym. This would be something to note on your frame because there is value of using corresponding parts of congruent triangles are congruent. Before we get there, we are just going to analyze and identify where our corresponding parts are. So in example 1, it gives us two polygons. And it says they are congruent by all of your tick marks that you see. And we are supposed to identify all the corresponding parts and write a congruent statement. So remember, corresponding parts, you have sides and angles. So I'm going to start by identifying all of the sides. So AB is the first one that I listed. I know that guy is going to be congruent to XW because it has two tick marks. So I'm just matching up those that are marked as being congruent. So two tick marks with two tick marks. BC was the next guy that I wrote down, and so it has one tick mark. So over here I'm looking for the guy with one tick mark, and I see I have XY. So I have BC equal to XY. Then I listed CD, which has four tick marks, and that would be congruent to YZ. And then last, AD is congruent to WZ because they both have three tick marks. So that takes care of all my sides. Next, I need to find all my angles. So I started with A. A has one arc, and so therefore it's congruent to W. I went to B next. B has two arcs, so therefore it's congruent to X. C has three arcs, so therefore it's congruent to Y. And then D and Z both have to be congruent. The last part of the question asked me to write the congruent statement. So all you have to do is, if you've already lined these up in order, and they're going in order around in a circle of your polygon, you just rewrite those names. So A, B, C, D has to be congruent to W, X, Y, Z. So in a congruent statement, you have to make sure that your angles are matching up with your corresponding angles. And then also all of your corresponding sides should be matching up. So like the first two, AB, should be matching up with WX, which they are. We just reversed the order a little bit. Okay, but it's still saying those two sides. So congruent statement, it is specific on how you write it because corresponding parts have to match accordingly. Pause the video and try the check question. So in the check question, they give you those two polygons, and you were supposed to fill in the blank. So I wrote that P was congruent to G, Q is congruent to F, R is congruent to E, S is congruent to D, PQ was congruent to FG. Now I do have to point out one thing when I was doing this. On the next set, QR is labeled with three tick marks, and I noticed that QR and SR are both three tick marks. So you want to look at their angle symbols to determine which one it corresponds to. Because first when I read it, I was like, oh, this has three tick marks. And then I realized both of these have three tick marks. Okay, so this arc here has three arcs and this one has two. So when I was looking, I had to make sure I found angles that had three arcs and two, and that would be the side that I want to use for the three tick marks. So QR has to be matching up with FE. Sorry, I was pointing to the wrong ones when I was looking there. Okay, and then RS is going to correspond to DE, and then SP is corresponding to GD. So just be careful. When you read those tick marks, make sure that they actually align. So if I were to flip this on top of here, which one would it align with? So QR would have to go with FE from the picture, and then SR would have to go from DE as you just visually look at it. Okay, so the second part is we're going to use our corresponding parts to help us find some variables. So in this diagram, they give us, get my stuff set up here. In this diagram, they give us that the two triangles are congruent. And that's a powerful statement because if they are telling us that the two triangles are congruent, all of their corresponding parts are congruent. That's that CPCTC that we can use. Okay, so what I did when I first looked at it is I started matching up corresponding parts. So these two guys are my right angles. And then I was noticing that in order for them to be congruent, angle R is congruent to angle T, S is congruent to angle V, which is why both of those are right. And then these two angles here have to be congruent to each other. And then I looked at their sides, so their hypotenuses have to be congruent. So that's why this side is congruent to this. And then your short leg and your long leg would be congruent to each other. So that's the first step, making sure you match up corresponding parts, because now it's super easy. Here I have 2y minus 1. I know that guy corresponds to this one over here, so I'm going to set them equal to each other. And that's why I did 2y minus 1 equals 24. Okay, so match up corresponding parts, and then you know they're congruent. So then we just solve it. So add it over and then divide. And then I also see that I needed to find this x. Well, conveniently, we already matched that angle with this one over here. Now, when I first looked at it, that angle is missing, right? So I would have to go through and find that angle. But luckily, if I'm in one triangle and I know two of my angles, I know my third. So if this angle is 78 and this angle is 90, I can find this third angle by taking my angle sum, 180, and subtracting away your 78 and your 90. And that's how I got this 12 right here. So I had to do a little bit of math to figure it out, but now I know that x has to be equal to 12. Okay, so corresponding parts are congruent if you know your triangles are congruent, so that's that CPCTC. And then once you've matched up your corresponding parts, you just set them equal because they have to be congruent to each other. All right, pause the video and see if you can do the check question. So in the check question, here was my setup that I was doing. So I matched up corresponding parts based off of my congruency statement. So I knew that AC had to be congruent to EC, and because they were in the first and third positions over here. And then I also knew that DE had to be congruent to AB based off my congruency statement because they're in the first two positions of my congruency statement. So then I set 20 equal to 3x minus 10 because those were the parts that were congruent. And then I solved and I found x equals 10. Similar scenario with our angles. I know these two angles in a triangle, so I can find the third. So again, I did the 180 minus 90 minus 38. And then these two have to be congruent based off of two reasons. One, they're vertical, but also because they are corresponding parts. Okay, so that is part 1 of section 5.2. Now we're going to move into part 2. So part 2 is where we're going to use some different, it starts off by naming a third angle theorem, and then we start writing out a proof. So third angles theorem is quite powerful. It says that if you know that two angles are congruent to two other angles in congruent triangles, therefore the third angle has to be congruent as well. We also know that all of these properties, reflexive, symmetric, and transitive, can be utilized again when you're doing these proofs. So you might consider that when you're getting ready to write out your proofs here in a second. Okay, so for this first one, it says, Aika is folding origami dragons for a party she is hosting, and that's showing you what you have over there. If angle ABD is congruent to CBD, and that's what I marked down here, and BAD is 58, we're supposed to find this angle CBD. So it's kind of similar to what we already did in the past. I would find this third angle, so start by finding things I can find out. So take 180, subtract away 90, subtract away your 58, and that's going to give you your third angle. And then third angles theorem, or also these two are already congruent, those two would have to be equal to each other. So that's why it's 32. Pause the video and try the check question up there at the very top. So you should have found the angle end up being 45. They told you these two were congruent right away. And then they said that ABD, or find ABD. Well, if I take 180 and subtract away 90 and 45, this guy has to be 45 as well. So pretty simple. Okay, now how can we use this to write out proofs? Okay, so remember when we're writing out proofs, we want to start with what we are given. Whoops. Okay, so on my first t-chart, I'm going to go ahead and make my t-chart, and then I'm going to fill in everything that's given. Then I'm going to come over to my picture and make sure everything's marked that was given. So J is congruent to P, JK is congruent to PM, JL is congruent to PL, and then L is bisecting KM. So everything was marked except for this last statement. Okay, so on that last statement where L is bisecting KM, remember bisect, it cuts it in half. So therefore, these two pieces are equal in length. So that is what I wrote down here, that KL has to be congruent to LM, and that's because of a definition of a bisector or segment bisector. Then I've taken care of everything in my given, and I'm looking at my picture and seeing, is there anything else congruent that I've not already marked? Well, here I also have vertical angles because I am making that X shape and they are non-adjacent. So therefore, I said JLK, this angle here, is congruent to MLP based off of vertical angles theorem. So then I'm thinking, what am I really trying to do? I'm trying to prove my triangles are congruent. And if I want to prove my triangles are congruent, I have to show all sides are congruent. Check, I've got that. And I have to prove all angles are congruent. Well, I got a problem. I have not shown that these two are congruent. So I'm thinking about how I would prove that. Well, I see that I already have two pairs that are already congruent to each other. So therefore, the third pair has to be congruent because of that third angles theorem. That's what we just got done discussing. So that's why I wrote angle K can be congruent to angle M based off of third angles. Now I've proven all my angles and all my sides, so I can write those two triangles are congruent based off of definition of congruent triangles or congruent polygons, whatever you want to use there. Okay, pause the video and see if you can do the check question. So in the check question, it should have looked like this. You started with your given, making sure everything was written down in your given, which it was. Then you're going to start analyzing and trying to find things that are congruent that are not marked. So automatically I see that I have two pairs of angles that are congruent. So I know my third angle is going to be congruent. So I wrote that W is congruent to Y. And then this is kind of new. If I am sharing this side on both triangles, so if I separated it, this would be the same length on both of those triangles. So therefore, this side is congruent to itself based off reflexive property. So this is going to be a big guy that you're going to use a lot. So you want to always see that and mark it right away and put it in your proof. So anytime my triangles are sharing this side, that side is always going to be congruent to itself. So that is why we write it in there. Now I've shown all angles are congruent and all sides, so that is why my triangles are congruent based off of definition of congruent polygons, or you can write definition of congruent triangles. Okay, folks, that is it for congruent triangles and in those corresponding parts, so CP, CTC.